everybody, and welcome back for task 4.4. In today's video, we have two learning targets. The learning target number one is going to be I can use inverse operations to solve linear equations in one variable. And these are going to be equations that have multiple steps. Learning target number two is going to be I can identify the steps used to solve an equation and support my reasoning. So, when we're solving equations, and I just want to do this as a review because we have done this before. When we are solving equations, an equation is a mathematical sentence that always has an equal sign. So you're going to know you're supposed to solve because there's an equal sign. When we are solving equations, we want to get the variable isolated. We can do this by undoing or moving all of the other numbers that are near the variable using inverse operations. Now, as we talked about before, it can be very helpful to start by thinking about how the equation was constructed and then working backwards to solve it. So let's look at problem number one. When this equation was made, step number one, if you start with x, was to add 2. After the person who made this equation added 2, step number 2 was that they multiplied by 6. Now, in order to solve the equation, we need to start by undoing the multiply by 6. So we're going to go backwards. Instead of multiply, we're going to divide by 6 first. And then instead of adding 2 to undo that, we're going to subtract 2. So we're going to reverse the order and also reverse the operation. Let's see how that's going to look. First, I'm going to divide by 6 on both sides. And I'm going to show division by writing it like a fraction. When I divide by 6 on the left side, the 6's cancel. So all that's left is the x plus 2. On the right side, 24 divided by 6 gives me positive 4. Then I'm going to subtract 2 because the opposite of plus would be minus. And when I subtract 2, the 2's on the left cancel, and all that's left is x. And on the right side, 4 minus 2 would just be 2. And that's my answer. Now, I can always check my answer by plugging it in. So if I take the number 2 and I go back to the beginning, 2 plus 2 is 4, times 6 is 24. So I know that I was right. For problem number 2, let's think about how you would build this equation. So to build this equation starting with x, we have times 3, then we have plus 2, then we have divide by 4, which means that in order to undo that, we're going to reverse the order. So first, we're going to multiply by 4 because that's the opposite of division. Then we're going to subtract 2 because that's the opposite of adding. Then we're going to divide by 3 because that's the opposite of multiplication. So we're reversing the order. Whatever was last is going to become first. And then we're also reversing the operation. So if it used to be multiplication, it's going to be division. That means that we're going to start by multiplying by 4. And that means that the 4's cancel. So all that's going to be left is the 3x plus 2. And 5 times 4 gives me 20. Then I'm going to subtract 2 on both sides, which means on the left side, the 2's cancel. So all that's left on the left side is 3x. And 20 minus 2 would be 18. And last but not least, I'm going to divide by 3. on both sides, which means I get x equals 18 divided by 3 is 6. Now I can always check my answer here by plugging that back in. 3 times 6 is 18, plus 2 is 20, divided by 4 gives me 5, so I'm good to go. Let's take a look at the next example. So if I was thinking about how was this equation built, first, whoever built this equation took the x and multiplied by 2. Then they divided by 5, and then they subtracted 7, which means that for me, if I want to solve that equation, I need to go backwards. So I'm going to start with whatever came last. Instead of minus 7, the opposite would be plus 7. Divide by 5, the opposite would be multiply by 5. And instead of times 2, the opposite would be divide by 2. So when I solve this equation, I'm going to start by adding 7, which means that on the left side, the 7's cancel. So all that's left then is the 2x divided by 5. And on the right side, 11 plus 7 is 18. Now I'm going to multiply by 5. And the 5's cancel, so all that's left would be the 2x. 18 times 5 would be 90. And last but not least, I would divide by 2. And if I divide by 2, I get x equals 45. Now again, I can always check my answer. 45 times 2 would be 90, divided by 5 would be 18, minus 7 would be 11. So that checks out. We're good to go. Last but not least, for problem number 4, whoever built this equation started by subtracting 6. Then, if you look at this fraction, we have the multiply by 3 is on the top. So that's the next thing that happened. They multiplied by 3, and then they divided by 4 because that's on the bottom. Which means to undo this, I'm going to start by multiplying by 4 because that's the opposite of division, dividing by 3 because that's the opposite of multiplication, and then adding 6 because that's the opposite of subtraction. So here we go. We're going to start by multiplying by 4. That makes the 4's cancel, which means we get 3 parentheses x minus 6 equals 21 times 4 would be 84. Then we're going to divide by 3 on both sides. And when I divide, the 3 divided by 3 cancels, so I just get x minus 6. And 84 divided by 3 gives me 28. And last but not least, I would add 6. And that means that I get x equals 28 plus 6 is 34. Now I can always substitute that back in to check my work. So 34 minus 6 would be 28. Divided by 4 is 7, times 3 is 21, so we're good to go. Now the second piece of today's target is going to be to justify our reasoning about the steps of solving an equation. So here's an example of a type of problem we might give you. It says 2 students are trying to solve the equation 3x plus 6 equals 11. Student number 1 thinks that the first step should be to add 6 on both sides of the equation. So student number 1 thinks that the first step should be to add 6. Student number 2 thinks that the first step should be to subtract 6 on both sides of the equation. Which student's first step would lead to a correct solution? Student 1, student 2, or both? Justify your reasoning. Well, if I look at this equation and I think to myself, how would I solve this? My first step would be to undo the plus 6, which means I would start by subtracting. So that tells me that student number 2 is correct. I would say that student number 2 is correct. And then I need to explain my reasoning. So to explain my reasoning, here's how I'm going to do that. I'm going to say because first we need to undo the plus 6 in the equation. And subtraction, which is what student number 2 thinks we should do, is the inverse operation of addition. So there are a couple important things in how we justify our answer. We need to say what was the first thing we were trying to do. The first thing we were needing to do was undo the plus 6. And then we need to say why subtraction is the right way to go. And we would say subtraction is the right way to go because it is the inverse of addition. That vocabulary word, inverse, is really important here because it tells us that that's how we undo the adding. So you need to make sure that when you're explaining your reasoning for a problem like this one, you always use the word inverse as part of your sentence. That is it for today. Thank you guys so much for watching, and I will see you soon for some practice.